All right, gang, good morning. That might be as good as I'm going to get at 8:30 this morning, isn't it? So, welcome to day 2 of Tech Ed. It's my day 1 of Tech Ed. I had the fun experience of the Atlanta International Airport and Car Care Center last night. So we got in a little bit later than we'd like to. But today we're going to talk about building Tier 1 solutions on analysis services. And what that really means, other than I'm trying to win for the longest possible title of a Tech Ed session, what we really want to talk about is what are the things you want to consider and make sure you have in mind and things you're going to experience as your analysis services environment begins to grow beyond that departmental level type cube. So when you're going from the 20, 40, 100, 200 gig range up to the 300, 500 terabyte kind of range. So just quick show of hands, how many of you guys are already using analysis services? Good. Picked probably the right session. How many of you have a cube that's bigger than 100 gigs? 300 gigs? 700 gigs? Couple. Terabyte? 2 terabytes? Okay. All right. So my goal here today, normally this session is presented by some folks from the SQL Cat team, and Denny Lee and some of those guys out there who just do a tremendous amount of work around testing and retesting and validating different types of strategies for being successful in any area of SQL Server technology. Specifically, they spend a lot of time on the data warehousing and BI side of things, whether it's larger scale data warehousing improvements in SQL Server R2 or analysis services up in the terabyte range, whatever that is. So my goal here today is to fill in some gaps. So hopefully we know that collectively we know more than one person. So my goal is to try to take a lot of the collective information that we've sort of gathered from SQL Cat, from testing, from the Analysis Services Maestro program that we've just put together recently, and from a lot of experience with working with organizations like yours, and kind of put them together and just talk about some of the things that you're going to want to think about and some kind of proven strategies that will help you move forward. I'm going to try very, very hard to leave about 10 to 15 minutes at the end for questions. All right? So, for those of you who don't know me, I'm Adam Jorgensen. I work with Pragmatic Works. We're based out of Jacksonville, Florida. We're a SQL Server, BI, and SharePoint solutions and software company. We do services and software all around the Microsoft BI stack and SQL Server, et cetera. So, that's all you hear about that because that's not what the session's about. So, when we talk about Tier 1 solutions, what do they really have in common? And what we're talking about here are really the much larger BI type solutions. So a lot of the things are going to come into play. Design and query considerations. High concurrent user count. Typically you're not going to have a terabyte cube with 3 concurrent users. Or you would have designed it a little bit differently, hopefully. You're going to have increased hardware requirements. Please do not come ask me a question about how you're going to run your 600 gigabyte cube on a set of VM blades. I'm just going to do this. It's not going to work, unfortunately. These solutions and systems are very I/O hungry, so we're going to talk about some strategies around I/O. For those of you running cubes in excess of that 500 terabyte range, you're already very, very, very familiar with these types of challenges. We'll talk about some real-time implications. A lot of people say, well, to get to the next level, it's less about size of data and more about latency or more about how often we can get our data into our cube. So there's some strategies there that we'll talk about as well. So when we talk about design and query considerations, there's a few things that we want to make sure we touch on. So simplicity is key, right? You're not going to have a 500 gig cube that's got 6,000 lines of MDX script in the back end. You're just not. It's not going to perform. So as you begin to drive larger data requirements and higher end analysis services environments up into that, whatever they call tier 1 type range, simplicity is key. You have to look at things like parent-child use and whittle that down. You really need to whittle that down. You got to look at things like many-to-many relationships and try to either avoid them or materialize them in a little bit different way. When we talk about query performance, we can talk about cell-by-cell versus block mode. How many of you guys have heard of this concept of cell-by-cell versus block mode before? Okay, so some of you. So when we talk about cell-by-cell versus block mode, what we're talking about is MDX and analysis services has the capability to eliminate basically empty tuples or empty sets when it does a query. So instead of reading row by row and scanning all the way through, which it can still do and up to a certain scale does pretty well, just like there's certain things in the SQL Server Relational Engine that we don't do on tables with millions of rows, there's certain things in analysis services that we want to try to avoid. So proper use of things like previous period type of calculations and things that are going to do ifs and case statements, you really need to watch those. There are some white papers that talk about a lot of this stuff and give you good examples for, hey, don't do this, and some very specific kind of nitty-gritty examples. And I'll make sure we call those out, towards the end as we kind of go through everything so you guys can jot down the names or get them off the recording. Most of those white papers, by the way, are out at SQLcat.com if you want to check those out. If you go to SQLcat.com and do a search for analysis services, you will get all the content that everything in this session is actually based on, because they've actually done a really good job of writing it up and pushing it out there and making it available for folks. Data types are also very, very important. So, for instance, converting a numeric data type to a big int will save you 11 bytes per value of storage, which doesn't sound like a lot, but when you have 50 billion rows in your measure group, partitioned or not, 11 bytes is going to save you a whole heck of a lot of space. So making sure that you're using the most effective data types for different types of operations is really going to drive a lot better performance. One of the reasons that we're concerned about data type is not just from a calculation perspective, of course, but from a storage, compression, data retrieval perspective. If we're trying to scan 40 billion rows very, very quickly for users over and over again, we want to scan the smallest possible row we can, right? Partitioning and locking. How many of you guys have had locking issues in your analysis services queues before? I'm sure you have. He's going to raise his hand all day, so you guys can. But I still want you to raise it, because if you don't, it'll tell me that I need to talk about something. When we talk about partitioning and locking, what we're really trying to obtain is a couple of things. One, we definitely want to separate things from a partitioning perspective for I/O, right? So that's really important. We want to be able to only work with the data that we actually need to work with. So if we only need 2011 data, we only want to go for 2011 data. We don't want to scan everything. Kind of common sense, right? But the other thing that it delivers is a much better model for threading. So when we look at things like processing and doing different types of processing, doing synchronization between multiple cubes, things of that nature, the better your partitioning strategy is, and we'll talk about a few different types of partitioning strategies, the better off you're going to be, because you're going to have much more flexibility when you go. If you need to move a year's worth of data and you have that in 12 partitions or 365 partitions, it's the same amount of data. But you can potentially request and enable more threads to move more of those individual pieces of data at one time, which is going to really speed up some of the things that you're able to do. What you really want to do is be able to push your I/O subsystem, your memory subsystem, and your CPU system to close to the limit, but have it go for that linear curve. And being able to adjust the threading model in analysis services is going to do that a lot more easily for you than trying to do it completely with infrastructure. So the more separate and disparate your data can become through partitioning, the better off you're going to be from a threading perspective, and the better off you're going to be from a locking perspective, because when you go to get that data, the locks will be held for a much, much, much shorter time and have a much lower potential to escalate up to potentially a measure group lock or et cetera. Distinct count performance. How many of you guys are using distinct count in your database, in your analysis services databases? I'm sorry. Distinct count has its challenges, right? From a performance perspective, there's no question. It absolutely does. And so one of the things that we'll talk about in a little bit, one of the case studies that SQLcat did is largely focused around distinct count and on really, really driving the read speed off of the I/O. So they have one case study where we'll talk about they did some short stroking on a very large EMC traditional subsystem, and then they have a solid state subsystem, the solid state integrated subsystem that they use that really took it even to that next level. So the other thing you can do to help keep your partitions separate, a lot of folks will partition on products or dates or time frames, et cetera, different sort of business keys. The other thing that you can do is to keep those partitions from overlapping is use hashes. So you can use hashes based on user ID, hashes based on products or dates or ranges, so that no matter how the data comes in, you're not going to have to worry about any of the partitions overlapping. When we talk about managing multiple user concurrency, there's a few different ways that we can do this. So one of the things that we're concerned about here is obviously needing to process data throughout the day, right? And as we're processing, we're kicking users out. We're locking them out, right? So what we need to do is we need to have a strategy in place that's going to allow us to process and bring in new data or accept new data and still have the users able to query from maybe a front-end analysis services server. So there are a few different techniques we can use. We can obviously use synchronization that's built into analysis services. Synchronization will work up until typically in around that 500 gig mark. Once you're above 500 gig, the built-in synchronization capability is not really going to keep up. It's just not. It's not designed for anything that high end. So what we do is we move to something like either a detach, robocopy, and attach, which is not a bad option. We have some folks actually using backup and restore with super, super fast disks. So they've got solid state underneath it, so they can do backups and restores very, very quickly. And the other thing is you can use SAN snapshots or clones. Snapshots typically take a little bit longer to create based on the terminology that your SAN vendor uses. I'm using typically EMC and HP terminology. The clone is typically going to be a little bit faster. So you can actually take that data, process it, take the other database offline, clone the LUN, and bring it back up. And as long as you have a few of those read-only databases up in front behind a load balancer, maybe the downtime is very, very significant, and that's what it should be. I mean, it's very, very insignificant. You can have multiple analysis services databases point at that same read-only LUN. So if you have a really nice high-speed LUN with lots of spindles underneath it or some solid-state drives, you can have multiple read-only servers point at that same LUN. So you can bring them all down and all up at the same time, or you can rotate. You can have one LUN per database, whichever one you prefer. As you can already tell, you're going to need to make really good friends with your system engineering folks. Very, very good friends. The folks who maintain your storage environment. How many of you guys actually maintain your own storage environment? Okay, so some of you. For those of you who don't and are going to have to go ask for some of these things as you start to grow, keep in mind that the first reaction from your SAN administrator is, what? You need what? And that's pretty common because in most environments, unless you're running a lot of data and you've already sort of set the stage for these types of environments, their reaction is going to be potentially a little bit knee-jerk, and that's okay. The goal is to have a productive conversation and explain what you're trying to do so that they can understand it. And when you guys see the deck, there's a couple examples up here of formula engine heavy and storage engine heavy queries where we've changed a couple of things out from underneath it and gone to multiple LUNs, multiple disk sets underneath, as well as looked at changing over the heap type from the analysis services heap over to the Windows heap. Anybody know why we would want to change from the analysis services heap to the Windows heap for running analysis services? Well, there's a lot of you guys in here. We're going to talk this morning. I got news for you. Anybody? It has better performance. Do you know why it has better performance? No? It's because the Windows heap is paging aware. The analysis services heap is not. So the Windows heap will realize, hey, I'm about to start paging. And it'll tell analysis services, hey, you're about to start paging. And it'll start cleaning up memory very, very quickly and start backing off. Now that may hurt some of your performance, but it's going to clear up a lot of those buffers and restore performance much faster. Analysis services will just keep going. Run, 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 run. Oh, I'm paging? Nope, didn't know it. Just keep going, 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 going. So the analysis services memory heap is not quite as intelligent as the Windows memory heap. They spend a lot of time building that Windows memory heap to work with a lot of different, very high-end applications, not just analysis services. We've got things like SQL Server, Exchange, all the other major enterprise applications. That Windows heap is supposed to be rock solid to work with those. So leverage that. It's very easy to do that. It's a change in the INI file. Yeah. Remote partitioning? Yeah, you can absolutely use remote partitioning. So what he's talking about is pushing partitions out to remote servers, letting them process there and be available for querying out and on different servers. That's another decent strategy as well, and there's nothing wrong with it. One of the challenges we run into with remote partitioning is largely just driven by whether you want to scale out the processing layer or whether you want to scale out the querying layer. So you have to decide, are you having trouble getting your data processed in time, or are you having trouble with front-end, more query-type performance, or both? Maybe it's both, right? So that's the thing you'll have to evaluate is, maybe I can process my data in a normal amount of time as I'm processing through the day and scaling out the query load, because if I'm not trying to query, I'm not going to be blocking my processing. But if I have trouble getting all my processing done and I need to scale that out, then using remote partitions is a really good option. We can set those partitions out on remote servers and say, hey, you guys either process on different schedules or the same schedules, et cetera. So one of the things we talked about a little bit so far is using solid-state drives or NAND devices in your enterprise strategy to help drive some of these increasing hardware requirements. So one of the things that's really going to help is solid-state drives typically have a much faster sequential and random I/O read speed. And that's really what you're looking for, especially on those read-only query server type databases. Also, if you're using something like remote partitioning or some of your processing, those NAND devices are really going to drive a lot of performance. And you'll see some of that in a chart that we have here in a couple of minutes. From a block size perspective, you really want to work on making sure that if you're running MOLAP partitions, that you're using that 64K block allocation size. If you're running ROLAP partitions, which is essentially everything relational, right, then you're going to stick with that 32K block size. There was some stuff out about a year and a half ago that confused that, kind of muddied that water a little bit. The CAT guys did a study, I think about 6 or 7 months ago, and retested all that with new enterprise SANs, checked against solid state versus non-solid state and all that, and pretty much verified that those block sizes are going to work the best for you. The other thing you may want to consider, if you have lots of storage capacity and you don't want to go the solid state route, because a lot of times maybe the SAN or the solution that you're on doesn't have a solid state expansion option, right, is you can look at short stroking your disk. So are any of you guys already doing any short stroking on your enterprise SAN? Okay, 1 or 2 of you. So when we talk about short stroking, what we're really talking about is telling the SAN, hey, you know that big platter that you have in the hard drive that it takes you so long to scan all the way across? We're not going to do that anymore. You're only going to scan the outer 30%. You're only going to write data to the outer 30%. Now, when you tell your SAN folks that, they're literally going to have a coronary. I'm just letting you know ahead of time. Just have the stretcher there. Just catch them. Be nice to them until they wake back up. And then tell them, no, really, I only need 30% of the disk, but we're going to use all of it. Yes, it's going to increase your storage capacity. That's life, unfortunately, in some situations. But it's a good option to compare cost. So you may look at saying, well, we could buy that new really fancy solid-state cabinet to go with our storage system. Maybe they say, well, that's so much money. And we say, well, the other option is we could look at only using 30% of the disk and buying an entire new cabinet or rack of just regular 10 or 15K drives. And a lot of times that's a better option. So that's one of the reasons that they test it, because not everybody can just jump to the solid state route. Yes?
I was wondering if you've seen any adverse performance as far as disk lifespan when you're going with short stroking.
Typically not. But that being said, I believe that they're going to perform pretty much along the lines of what you're going to see, because most of the time when a disk fails, it's not because of the head, it's because of the spinning mechanism. So what happens is that spinning mechanism wears out and it starts to catch. That's that clicking that you hear. It's actually not the head, it's the spinning underneath, and it catches. So when your laptop starts to go bad and you start hearing click, 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 it's actually stopping and starting, and that's the head stopping and starting at the same time. So typically we haven't seen a huge problem to where we wouldn't want to recommend it. But certainly if there's some information out there, you see something, I'd like to hear about it so we could look into it. The SAN vendors themselves are definitely recommending this. Not that that's a takeaway from disk life, because obviously they're the ones that are going to sell you the replacement disks. But in looking at whether it's solid state or short stroking or whatever it is, our biggest concern is around IOPS and latency. So we want to make sure that we're driving as much aggregate throughput to those individual different LUNs as we possibly can. That's going to be the most important thing. So whether you're going to be able to do it through solid state drives or short stroke disks or just regular, traditional storage, whatever it's going to be, just take a look at a couple of different techniques and try to see if you can test them out. The other thing you're going to run into a lot of times when you have very, very large cubes is you're going to need to get back into using roll-app. So how many of you guys are using roll-app in your environment right now? Okay, a few of you guys. Are you guys running that whole terabyte plus in MOLAP? Very nice. What storage do you have underneath that? What kind of storage do you have underneath that? Hitachi? Oh, okay. Direct attached HP. Okay. All right, very nice. So one of the things that we talk about with roll-app is obviously roll-app's going to give us a performance hit because we have to go to the relational database to get the data, right? So it's not going to be, typically it's not going to perform as well as a query speed from a MOLAP partition. But what we are going to get is the ability to really drive that latency to near zero. So you're going to get that data if the end users are saying, look, we need the data up to date as quick as possible. You can deliver that, to near real time, if not real time, but there's going to be a bit of a performance hit. So there's some ways to mitigate that and sort of, take roll-app partitions and migrate them into MOLAP partitions throughout the day. There's some things that investment banks do, and there's one of the case studies that we'll talk about where they're actually rolling daylight. So they've got partitioning based on time and location. So we'll talk about some things like that that are pretty cool, some kind of innovative things that that really you guys are the ones coming up with. So when we talk about improving I/O, can you tell we're going to talk about I/O today, guys? You should be glad Denny's not here. He'd be doing an hour and a half on nothing but I/O. We're going to talk about some other stuff too. You want to make sure you do partition alignment. So for those of you running Windows Server 2008, you shouldn't have to worry too much about this. It's handled automatically for you on the install. But if you're still running Windows Server 2003, there are some things where you need to go in and change the partition alignment as you're setting up your OS to make sure that the block size and everything on the disk is going to line up okay and perform optimally. There's a really good MSDN article out there about that. When we're looking at storage engine performance, not engine performance, we want to make sure that we're writing queries and doing things that are not always having to go down to the lowest level to get the data, right? We want to be conscious about how we're designing aggregations, and this is on MOLAP. So if you're actually going to go out and write queries and run reports, et cetera, against your cube, and it's not just ad hoc end user access, we want to make very, very sure that the MDX that we're writing, that we know what it is, so that we can go back to the cube, and if it's the same person or different folks, and collaborate and say, these are the levels of granularity that I'm asking for things on. Please make sure that we have aggregations to support these. The nice part about that is if you use a roll-app or some type of hybrid OLAP, you will be able to hit those aggregations very, very quickly while not having to go all the way down to the source data. Even if you have to go to the source data, a lot of times having that aggregation built in the source data in roll-app is going to help you a lot. When we talk about roll-app, what we really are looking at there is trying to do transparent aggregations. So has anybody heard the term transparent aggregations before? Okay, one or two of you. So when we talk about transparent aggregations, what we really are talking about is the capability to surface data at different granularities inside the relational engine so that we can hit it with roll-app and it looks like an aggregation that it would see in MOLAP. And the way that we do that is by not using table binding. So obviously, by not using query binding. So a lot of you, as you've been growing, you've heard, hey, it's a best practice to use views in your analysis services database, right? Because you can tune the query, you can manage the locking. I've said it, I've taught it to people. And it's right, up to a certain point, just like anything else. Then you get back to a point where you have to start using table binding because underneath the covers, you're going to have to go from, you may have to go from a partition table to individual tables. And the reason why is to do the transparent aggregations, the best way to do that is with an indexed view. If you put an indexed view on top of a partition table, when the indexed view runs the query, it's going to use subqueries. You do not want those subqueries to run. That's immediately going to kill your transparent aggregation. So if you notice that the queries that are running against your roll app environment are executing subqueries, you need to look at potentially changing the design. The nice thing about that is it's really easy to spot and typically fairly easy to fix because you can see exactly what the subquery is running against, why it's not getting it, and then begin to split that data up. The other thing that's going to help get rid of that subquery is how many of you have used that default count measure that you get when you build a measure group? Right? It's pretty good, right? I've used it. You're not going to get to use it anymore. I'm just taking stuff away all morning. That's always going to drive a subquery because of the way that it's built. So you want to try to avoid using that built-in count measure if you start to see performance problems. The thing to keep in mind is a lot of the stuff that we're talking about up here, you're not going to do all of it. You may only do some of it, or one of it, or two of it, right? There's going to be situations where your bottleneck is either on the processing side or the querying side, or you just fix some I/O and some underlying issues and a lot of your problems go away. The thing you want to understand is some of the things that you can do as you're growing to make sure you're taking advantage of all the functionality that's there. So please don't go back and go, I have this list of 150 things we need to change in our queue because it's at 200 gigs now. Don't do that. If it's working, congratulations, you did a great job. What you just need to be aware of is these are the types of things that you'll run into as you continue to grow. There is a best practices chart for the underlying I/O in the pre-deployment I/O white paper for SQL Server, and there's a listing for it out on SQLcat.com, and it's got kind of a really nice checklist for all the things you'll want to do specifically to I/O to make sure that your SQL Server environment is set up from an optimal perspective. So we talked a little bit about partitioning, and I know some of that text is a little bit small, so I apologize. The joys of the Tech Ed PowerPoint screening crew. But don't be afraid to make your partitions smaller. A lot of people run away from a very high number of partitions because they it's too hard to manage. 50 partitions and 5,000 partitions should be managed pretty much exactly the same way. You just happen to have more of them in the bucket, right? So if you have a decent strategy to manage the 20 or 50 that you have now, hopefully that strategy is something that either can be implemented or tweaked, not rewritten, to work with a larger number of partitions. And the one thing I wanted to show you here is this is an example, I believe, from Yahoo's Cube. Yahoo's Cube, when SQLcat did the white paper for them, I think it was around 12 terabytes. Now it's 18 terabytes. Running on analysis services. This is an example of a type of the processing and the partitioning that they did to help with some of their processing and querying. So they were looking at underneath in one of their fact tables a partition per day, just monthly, right? Just rolling partitions. But when they got to the cube, they actually did 8 evenly spread partitions a day because they figured out that from a processing perspective, 8 was their optimal number. They did testing, they looked at their threads, they went through all their benchmarking, and they figured out 8 partitions is what we can process the fastest and most efficiently at any given point in time. By the way, when you talk about scaling out, Yahoo processes 48 running threads of processing at any given point in time. Constantly. Always running. Always, right? The reason that they can do that is they're employing a couple of different things. One, they're going to employ things like remote partitions. They're also employing a whole bunch of front-end query servers that are being synchronized. So there's a lot of technology that goes into these very large enterprise systems, and I think a lot of times folks tend to overlook that because, well, it's BI or it's a cube or it's analysis services. We don't have to put, we can put that on VMware or we can put that on Hyper-V. Stay away from that mentality. If you want it to perform, you have to give it the tools to perform for you.
Adam?
Yes?
I read in the performance white paper that there was a recommended threshold of about 2,000 partitions. I know that Yahoo Cube is using about 7,000.
Yep.
So is that old news, or what's the story behind that?
Yeah, that's a good question. So for those of you who didn't hear the question, there is a white paper called the Analysis Services 2008 Performance Guide, and it's a really great if you're needing to do this type of thing or having trouble sleeping. And I'm kidding, but it's obviously a lot of really, really in-depth information. Yes, and it's thin too, isn't it, Paul? Yes, you can roll it up and make a pillow. It's got lots of uses. But it's really kind of the definitive work that compiles all the different, sort of recommendations from all the different white papers. So it's a great place to start. And then when you say, I need a little more information about this, you can jump over to the white paper that kind of specializes in that. Paul's question was about, hey, there's a recommendation in there that says try to stick to around 2,000 partitions as your max. That's one of the first questions we asked last time we were up here, and the answer was, it's more of a guideline than a rule. So to your point, Yahoo's using more than triple that. We've got some other large analysis services installations that are using more than double that. What it really boils down to is, can your storage subsystem handle it, and does it make sense? Just like anything else, it has to make sense. So for Yahoo, it makes sense. For Xbox Live, it makes sense. For Pragmatic Works, it would not make sense. We don't have that much data. We don't have that kind of infrastructure that we need to support that. So, good question. Yes?
What's the maximum number of partitions?
I knew somebody was going to ask me this today. There is a maximum number. It is very, very high, but I do not remember it off the top of my head. I do remember the last time I asked the cat guys that question, the answer was, you won't hit it. And if you do hit it, please call us. So one day I'm going to write an SSIS package that's just going to start generating empty partitions just so I can see how many empty partitions I can generate. But unfortunately, I haven't had a plane flight long enough lately to make that happen. So
It says unrestricted.
yeah, unrestricted. The most dangerous words in databases I've ever heard. There is no limit. There is a limit, and but they won't swear to a number. So, if you guys run into a limitation, by the way, or a serious limitation from a performance perspective, where you go from, let's say, 1,000 to 2,000 or 2,000 to 2004, and it roadblocks you, please let me know. Let the SQL Cat guys know. Email them right off their website. They'll be more than happy to try to engage and take a look at it, especially if it's a large cube project, because they really love that kind of stuff. Yes?
How partition count influences the dimension processor date time?
So how does the partition count influence the processing for dimensions?
For dimensions processing update.
Process update. So if you're going to do a process update is typically a little bit slower than process add, obviously. Partitioning is really going to help from the perspective of if it's got to go in and actually update associated measure data to go along with it. Theoretically, if you had smaller partitions, it could thread that out a little bit better if you had enough threads assigned to it, and it should theoretically enhance the performance.
Quite different. That each partition has a header file.
Right.
So if I update the dimension, each header file must be updated too.
Correct.
If I have 2,000 partitions, so its update time will be 6.
Yeah, so if you're running a process update, that's one of the reasons that update's going to take so much longer, because it's got to go back, because you can have dimensional changes in process update as opposed to process add. One of the things that's typically a recommendation is to try to avoid process update if you can, just because there is so much back that you have to do. That kind of falls in the realm of, as you start backing out functionality as you get larger, you have to start looking at ways to potentially avoid things like process update. Sometimes there's not a way to avoid it, right? It seems very clear-cut to say, oh, don't use process update anymore because you're too big. Well, maybe that's not a good answer, right? Sometimes you have to do those types of things. But, his point, if you couldn't hear it, was every partition has a header, and that header has to be updated if you're using a process update, because that dimension data could change, retroactively and affect any one of those partitions, so it all has to go back and be updated. So when we talk about real-time implications, there are some techniques for real-time. Proactive caching. How many of you guys have used proactive caching before? Okay. How many of you guys have used, well, we talked about roll-app a little bit. How many of you guys have done any incremental processing where you move roll-app data into mole-app partitions? Okay. This is the one that I start to see more and more people using. So obviously, some users are going to need to query the last 10 years of data that you have in your cube. Right? Some of them are going to have to. Hopefully, you have some situations where some users don't have to do that, where they don't need to scan every single partition for the measure group every single time they're doing a query, right? Hopefully. Sometimes not, but hopefully. The important thing to remember is you can take some of those partitions and set them as mole-app, and as you begin to reprocess incrementally, as you move through your day, or even nightly, or weekly, etc., you can start to move some of that older data and keep the newer data in mole-app and move some of that older data out into roll-app. Think of it like an archive table, almost, except it's all in the same measure group. So as you set up your partitions, keep in mind, what are people going to hit the most versus what are they going to hit a little bit less, and try to make sure that you're rolling those forward. If you're going to handle it for a real-time situation, you may need to leave all those partitions set to roll-app, and you may need to do the opposite. You may need the most recent data as roll-app, and you may be able to put some of the older data in mole-app if you don't have a storage constraint there to make that happen. So there's a few things that you can do from either side of that coin to try to help drive getting the end user's data either very, very quickly or making sure that the latency on it from a delay coming from the operational system is very, very low. Did you have a question? Is there a consideration for the trade-off between number of and size of partitions? Yeah, absolutely. So the biggest consideration there is how many of those are you going to have to process? How many can you do in parallel? And how fast is your system? Is really the driver. If you have 3 very, very large partitions, you're only going to get so many worker threads on 3 partitions. So if they're very, very large and they have to be reprocessed and there's a lot of work to do there, that may take a little bit longer than having 9 partitions that are a little bit smaller that could all individually kick off at the same time. The thing to consider there is if you go kick off 9 partitions processing, how's your underlying data store going to perform? So a lot of people spend a lot of time focused on the analysis services side of things without thinking as much about, hey, once I really throttle this baby up, it's going to kill my underlying system, whether that's my MART or my data warehouse, or whether that's just sitting there to process analysis services, which in a lot of cases is the case. It actually, the data gets loaded twice, one to a data warehouse or a MART that's going to be used for more end user style reporting. And we even have some clients that have a completely separate copy that's only used to process the cube. So they can hit it as hard as they want, and they're not going to worry about impacting any users. So when we talk about some proven strategies, what I mean by this is it worked for this customer. It does not mean it will work for everybody. It just means this was very, very heavily vetted. One of the nice things, and one of the things I would encourage you guys to do, Microsoft does a very, very good job of reaching out proactively to their larger customers. One of the things that they can sometimes struggle with is seeing and understanding what customers may not be the largest companies, but may have the largest amount of data. There are a lot of data companies that have 15 employees and 200 terabytes of data that they're manipulating, right? So the thing I would encourage you to do is get in touch with the guys on the SQL Cat team. Reach out to them through the website. They have a form on there that says, hey, are you guys doing these types of things? We want to hear about it. We want to partner with you. They have lab resources and MTCs that are regional. They will definitely, if you have a really great unique use case and you want to explore it and you want to figure out what it takes to get to the next level, they will be very good about trying to work with you and interact with you and at least either point you in the right direction or bring you in and get you some really strong resources from their team to help really drive a lot of value there. So when we talk about big installations, we're talking about 3 today. One is Microsoft Ad Center, which is the ad system that runs, originally it was by itself, now it's behind Bing. There's Xbox Live, which is, if you look at the case study, it's actually branded Microsoft Entertainment Division. And then there's the Yahoo Cube. So a little bit more about the Cat team, just a couple of examples. We've talked about the Cat team. Their whole job, their whole existence is to work on the hardest, most complex, roughest, gnarliest SQL Server related installations on the planet. That's it. They go to work every day knowing somebody's got some problem that's going to try to stump them. So, the nice thing is when you call and you talk to these guys and gals, they are incredibly sharp, but there's a lot of sharp people in this room. They're bringing the collective experience for the stuff that they've actually played with and implemented and turned on and turned off and all that kind of stuff. So MySpace is a good example. Over a petabyte store, they've got bwin, which is a giant European online gaming site. Over 30,000 transactions per second. Korea Telecom, some major installations. One of the big installations back in 2005 was when Hilton Hotels, the Hilton Hotel Group, converted over from and upgraded to SQL 2005 for the entire operating system behind Hilton. So reservations, everything behind Hilton is now running on SQL Server 2005 for the most part. All the major systems, at least. So when we talk about Ad Center, you're going to see a few terms up here that we've already talked about. So they're running an EMC DMX VMAX, which is a really long acronym for very, very fast storage. That VMAX is dedicated, right? So they're not worried about, hey, is Exchange sharing this LUN, or is the file share sharing part of this LUN over here, and am I having a problem? No, they said, we got to have this work. It's got to work well. We're going to make sure that the DMAX is dedicated. Hundreds and hundreds of spindles and disks are devoted, to the process. They have short-stroked all of those disks. So they looked at the solid-state option versus the short-stroking, and they actually came out better on the short-stroking side. So solid-state's not a magical fix for everything. That's the important thing to remember. They did test a lot with the EMC flash drives. Now, I will tell you, this case study, I want to say it's about 1.5 years old. So in the solid-state world of things, 1.5 years is basically like a decade, right? Everything's moving very, very fast. We've got a lot of companies who are doing some really incredible technology. So continue to evaluate those different things as an option. They work very, very closely with vendors. The nice thing I will tell you is if you are using a lot of data and building a tier 1 system, your vendors should love you. Not only are you going to be buying a lot of equipment, which is good, right? But they can use you as an example and go, look at this great company that we helped, and look how great their system runs. And in order to do that, you can get very demanding. You can, be a celebrity and say, I want engineers to come help me spec this out, and I want this, and I want that. And they'll give it to you. That's the important thing to remember. You don't have to do a lot of this on your own. You can go out and say, hey, I have this really cool, unique situation, and people should be paying attention to me. Make yourself kind of a big deal. Tell your vendors that. Say, hey, listen, we're looking at buying and possibly short-stroking, more than 1 terabyte of storage from you guys, which means we may need upwards of 5, 6, 7 terabytes of raw space. Everybody says storage is cheap, but that's not chump change, ladies and gentlemen. I couldn't go out and write the check for it today. So you need to be aware that you have a lot of leverage in this process too. You're not just the person who has to build it, right? You're the person who gets to drive it. And that's the thing I want to remind you is drive this effort. Don't just be a part of it. So if you want to reference, Ad Center is doing some pretty cool things. There's a case study out there specifically on Ad Center with a lot of these graphics and a lot of the comments and nuances. But they're basically loading into a staging data warehouse. They've got a dedicated OLAP processing server, and then they've got a standby server. And they flip between the standby server and a front-end server just using a load balancer. So they process one, and they process another. And they process one, they process another. So they always have one very, very sizable query server that's available, and they just use a load balancer to flip back and forth between. Now, how many of you, I know some of you manage your SAN, how many of you also manage your databases, like SQL environment, Oracle environment, et cetera, DBAs, okay? How many of you also manage your network? Yeah, so that's where you're going to have to ask for some help. And when you go in and say, I want to be able to control the load balancer with a PowerShell script, if any of your network admins go, yeah, sure, that's no problem, you might want to reevaluate who your network admins are. You want to make sure, take them out, buy them some dinner, buy them a drink, be very nice to them. But this is load balancing 101 kind of stuff, right? Sticky session load balancing 101. This is not complicated stuff. So you just want to make sure that you have a good idea and give them a good idea of what types of applications they're going to be hitting it with, if it's reporting services, if it's a Citrix farm. One of the things that an investment bank did, which we'll talk about in a minute, they're using a Citrix farm as a front end to alleviate a lot of that network latency. So they put that Citrix farm on the same network backbone, et cetera, to alleviate a lot of that latency, and they can do all the load balancing and management of that internally without having to worry about, the fact that they got 5,000 people out in the field that are all going to be hitting this. So they actually needed a partition by user. So they want to be able to query data based on individual users and companies. So rather than have user data that may or may not overlap, they wanted to be able to get very, very, very unique. So they're actually using hash values of a combination of the user ID and the person's name or company name, which is giving them a very good, unique, partitionable ID to work with. You guys don't have to necessarily look at using hashes. You have, integer identifiers that you can use. But because they needed so many partitions to look at doing very, very individualized processing for different types of reporting, this was a better option for them because it gave them a broader data range to be able to select from. We talked a little bit about the importance of I/O, right? Just a little bit. And one of the things that you'll see here, and it may be a little bit hard to read on the slide, so I apologize, but essentially what we're looking at is a combination of hard drive tests and solid state tests. Obviously, that big pink line going for the ceiling, that's a hard drive. That's actually the enterprise SAN that they were running on to do the test. The orange line that runs right through is a slightly improved version of the cube. They went through, rewrote some queries, made some very basic modifications based a lot on what you'll find in that Analysis Services 2008 performance guide. And then they loaded that cube on a set of solid-state drives and drove 506 seconds for 7 months of data, as opposed to a little over 2,800 seconds for 6 months of data. So the performance is pretty significant. By the way, all this was generated with about anywhere between 50 and 60 outstanding I/O requests. This wasn't just, hey, go server by yourself and hit run. So they put a base load on the server to sit there. Cache was warm in both cases. Very, very important to point out. Everything was done to try to make all the queries run as optimally as possible. It was designed to be an I/O test, nothing more. The one thing I will say is because of the types of queries, because we're using distinct count, a lot of times we don't take advantage of aggregations. So that's why distinct count is a great query to look at I/O performance, because a lot of times you're not going to hit those aggregations and you're not going to hit cache, because distinct count it's queried a lot of different ways. So that's going to almost routinely go down to the leaf layer and hit the I/O. So one of the things to think about if you're looking at pushing your system a little bit further is, can we take advantage of some of that solid state performance? So this is another graph that just shows the same query that we just talked about, but instead of running it once without standing requests behind it, we ran the query 1 at a time, 6 at a time, and then 12 at a time. You'll notice the curve. Fairly significant, right? The SSD's ability to bring data back quicker frees it up for those sequential I/O efforts. So you're getting a lot more throughput from even a smaller number of SSDs for a lot less power and all those things that they use to sell you on SSDs. But at the end of the day, the performance speaks for itself. So if your spindles are not able to keep up at the concurrent level, you may want to do some benchmarking specifically around the solid-state space to see if that's going to be a good option for you. So when we talk about Yahoo, and this slide has about 11 animations on it, so I'm just going to do them all here, and that way we can work with it. Okay. Yahoo's loading a ton of data from a number of files, right? So they've partitioned. They're actually a great example. One of the questions I get asked a lot is, well, can we run Microsoft BI in a big way without SQL Server underneath it? The biggest installation in the world, unfortunately, has 10G sitting underneath it. That's just the way it is. Enterprises have different enterprise systems for different reasons. So Yahoo happens to have Oracle 10G. They're loading about a tera. Now I think it's about 1.8, 1.9 terabytes a day. That volume has increased since the graphic. This is the exact graphic that's in the white paper, by the way. So it is slightly underscaled from a size perspective. They've got the Oracle 10G system partitioned. They've got the cube partitioned. And they're actually connected also to very high-speed direct attached storage. They are now, as of about 4 or 5 months ago, leveraging solid-state drives as well for their processing server and for some of their read servers. Once the processing is done, they're constantly running processing. And they're actually doing storage-level snapshots and clones in the back end to make sure things are synced up and replaced. They have, that has 3 query servers. I think at last count they had around 30 to 35 query servers sitting up front. So it is a relatively sizable implementation and has its own team basically dedicated to the BI infrastructure that's coming out of that environment. One of the things that I get asked a lot is if we are looking to improve the way that we do load balancing or get into load balancing, can we use ASLB? How many of you guys know what ASLB is? ASLB is basically a free load balancing solution that's out on codeplex.com. And it works. There's absolutely nothing wrong with ASLB unless you're trying to move terabytes and terabytes of data. So if you're going to be doing a large production scale implementation, you need a hardware-based load balancer. You need an F5 or something, a Cisco or something comparable that's going to be able to handle the scale and speed at which you want to do switching back and forth, not something that's software-based. But those are expensive, right? So projects will never get off the ground if you walk in and go, I need $4 million in equipment and we can start tomorrow. No. That's not going to happen. So what you can do is you can build a mock-up of this using ASLB, and that's why I bring it up. So you can use ASLB and mock it up using a couple of Hyper-V machines and just put a sample load through it. You're not going to push 50 terabytes through it in the middle of the afternoon, but just put a sample load through it, 15, 20 gigs at a time, just push it through so you can actually demo it and kind of show off what the user experience would be, et cetera. That would probably take anywhere from a day or 2 to kind of set up. So if you can carve some of that time out as you're looking to grow, that type of solution where you can actually sit down and show the end users and show the IT infrastructure and management folks, what that's going to look like on the back end, that's going to give you a lot of, credibility as you go in to try to, take this to the next level. I like the last animation where it says data is going to the person. So we've got some large investment banks that I believe in the white paper are unnamed, so I will not name them. And they're largely concerned with locking. So they've got a worldwide presence, right? They've got traders all over the world. They've got offices all over the world, different currency markets they're engaged with. So they need to be concerned about getting data, obviously, very, very quickly to the users. They don't want to wait for processing. They don't want to wait for a lot of these things. So they are largely employing roll-up scenarios. Even though they're a little bit slower on the query side, they need that data as soon as it's available all across the world. They are also one of the clients that's using a Citrix infrastructure to sort of web front end a lot of that. Because that way they're not trying to push data out to Hong Kong and over to Europe and over to the West Coast and over to other places in Asia. They're not going to handle all that. They can process it all centrally. They have two solutions. They have one in Europe that handles Europe and Asia, and they have one in the U.S. that handles the U.S. And part of the Pacific and Australia. Now, the reason that they do it that way is just to avoid having to buy so much hardware in one location. So it was just a mitigation strategy. There was no real performance one way or the other. They would have had to put it all cumulatively together anyway because all the data is actually still there. They're snapshotting a lot of that data over the wire nightly to make sure the data gets caught up. So certain data is not available until the next day. Certain data is. But one of the things that's really important to remember is they're going to have to deal with locking. And so the reason that they scale out and the reason that they're using roll-up is because they don't want to wait on the schema lock and the database lock that has to be taken when you process a molap partition. They can't do it. They have too many people trying to hit the data all the time. So what will happen is their processing will either time out. Their processing will time out. Long-running queries can actually block processing. So how many of you guys have actually looked at the short and long thread pools in analysis services before? How many of you guys have heard about that? Okay. So you know there's, so for those of you who haven't, there's basically two thread pools that you get in analysis services, short pool and a long pool, very creatively named. The short one is for, what do you think it's for? Really? Short queries? So things like discover statements, very short little XMLA statements, very, very quick MDX statements. Those are evaluated by the query engine on the way in, and he says, it's small enough, send them over there. Or, oh, no, you're going over there, you're going to wait in line. So the long query pool is for most of your queries. I would say 90% of your queries are going to go through that long pool. Anything that needs an execution plan created for it, anything that's going to need to issue multiple discover statements to run, that's going to go through there. If the discover statements are going to come around and run through the short pool, but it's going to go through there. The problem is, guess where processing goes through? Long pool, because it's not short. So processing can actually be blocked and held up by long-running queries. So if I'm an end user and I'm saying, oh, I want to see all my trades, I don't want to see my trades, I want to see everybody's trades from the last 6 months, I need to do some trending analysis, go. And that could potentially take a little bit to run, especially in Rollup, right? Because we may, it's going to take a little bit longer. We got to aggregate some of that data. In the meantime, my scheduled job comes in and says, hey, I need to process, ready to go, give the user some new data. And the analysis services says, no thanks, buddy. Hang out. You're going to wait. So the processing job could actually time out, which would then impact their data availability. That's pretty important to a financial institution because they're quoting things based off of those numbers. So that's pretty important. If you're basically quoting on a 15-minute window and your processing doesn't update for 45 and that price has changed significantly, or you should have put an option in and you put instead of called, you've got a few issues. More than a few. Maybe some regulatory issues. So you really have to make sure that you understand what the end users are looking for to make sure you can deliver a solution that's going to drive what they need. And again, the major areas to look at are going to be, when do they need the data? How soon do they need the data after it comes in? Once you've looked at that, how much data is it? Do they only need some of the data? Can we find a compromise? Is there no compromise? Do they need all of it? Then once you know how much data it is and how soon they're going to need it, then you can start backing in and saying, okay, how are we going to surface this data to them? What are they going to use? Are they just running reporting services reports? Are they running a custom application that's generating MDX on the fly? Are they running Excel? Are they running, what are they running? Are these dashboards? Are they performance point dashboards? What are they? How much control do you have over the queries that are actually getting executed? Or are they being sort of dynamically generated by an ad hoc tool? So based on a lot of those types of decisions, you're going to be able to say, well, I'm pretty sure I'm not going to have a lot of problems with my formula engine because I can control my queries, so my storage engine side is where I need to optimize the most. Or vice versa. I'm going to be doing a lot of time processing and evaluating queries because they're going to be coming in hand over fist and I'm not going to have a lot of control over them. So I need to make sure that I design for both as best as we possibly can. So when we talk about loading that data in, Rollup was actually one of the better options for them. That's not the case in a lot of situations. In a lot of situations, you can use Rollup for large data if you have enough processing power and you're not concerned about the locking and the weight. If you can do the load balancing and handle it, then you may be able to avoid having to use Rollup. So relational locking is the same exact story. So how many of you guys are using partition switching in your data warehouse or your data mart? Yep, so a few of you. How many of you know what partition switching is? All right, a couple more. So when you partition a SQL Server table, you have the option to create those partitions on the same or different file groups, right? A lot of folks will put them on different file groups, so you have a little bit more flexibility. You can put them in different places, and that makes a lot of sense most of the time, except for the fact that when you want to switch a partition from one table into another table, which is a pretty common practice if you're loading data or offloading data, if you have it on different file groups, it has to physically copy all that data from one file group to the other, which can take a little while, right? So you're going to have a lock, you're going to have weights, you're going to have all this stuff added into your workflow that you're trying to avoid, right? What you want to try to do is make sure those are on the same file group That way it's a metadata-only switch. So you can switch in a partition, and it will take milliseconds. So you can switch in 150, 500, 800 million rows, and it pretty much runs like that. Largely because all it's doing is changing the metadata under the covers. It doesn't have to physically copy that data again. Now, when we get to a point in analysis services where we're concerned about the switch merge lock actually causing us some delay, you guys are definitely running a tier 1 system because that is not a very long lock. However, it does take a schema lock, and so it's going to lock more than just that individual partition. So you need to be aware of that. So the thing to think about is one table, not a big deal. If you have 150 tables, 500 tables, somewhere in that range, constantly switching in new data, now you've got more than just a couple milliseconds of locking and blocking going on. So you just need to be aware of that. You need to be aware that that switch, even though it is very, very fast and it's a great option, will actually block some queries. So that switch process could block processing if it's not completely done before you start doing that. You need to be careful when you're inserting into a partition table, if you're bulk inserting especially. If you don't have that data sorted or apply an order by that's going to match the sort order of the table from a clustered index perspective, SQL Server is going to sort your data for you. How many of you think that's going to be good? No, not this guy either. That's going to be slow. Any of you guys have ever played with bulk inserting a lot of data into a partition table? Know exactly what I'm talking about. The very first time you did it without an order by, you probably went to lunch, said, I'll come back, this will be done. You came back, it wasn't even close to done. And hopefully you killed it and waited the rest of the afternoon for it to roll back. So adding that simple order by and sorting things ahead of time, keeping those small batch sizes so things will commit in batches so that things can continue to process behind the scenes is going to be really, really important. So the other option, which we have on the slide, is you can partition and process into a completely separate table if you want to. You can use duplicate tables. The nice thing, and the thing I really like about coming from the OLTP world over to the BI world, is a lot of times if I go, how can I solve this problem? And you come up with a solution, if there's no glaring problem with it, it's probably okay. Whereas in the OLTP world, there's a little bit more specific design patterns that we want to try to attack and certain things we want to try to avoid. Same thing in the BI world. But a lot of times we can do things like, hey, why don't we just create an extra set of tables and process out of those? If you go tell your website developer, hey, we just want to create an extra set of tables for everything in your website. Can you just do that? Is that going to be cool? We'll just select out of those tables. They're probably going to not be very happy with that. But in the BI world, we can do that. We can say, hey, let's just make an extra set of tables. We can put those on separate LUNs, and we can tell the storage guys we need more storage. And you can see how this is going to grow a little bit, right? It's going to get big. Tier 1 is not small, typically. There's some things that are associated with it. But the nice part about it is once it's running, boy, is it awesome. It really, really, really delivers a lot of bang for the buck. So one of the things we want to be very, very cognizant of is managing the actual locking in our relational schema, especially if we go to a system where we're not using one large partition table, but where we're using lots of smaller individual tables, because we can do switches on those as well. We can have just one partition on that table and switch things in and out, move data in and out, and have it be just a metadata-only switch, and there's some pretty cool techniques that we can do for that. We can also do MOLAP switching, so we can actually switch partitions in and out on the MOLAP side. We can also just switch cubes in and out on the MOLAP side. So you guys have seen a little bit of that cube flip we talked about earlier, where we can process and rename and switch things in and out. There's a lot of good strategies around that as well. A lot of it just depends on how long it's taking you to process and how much time you're going to have to actually make the switch, and if you can make it during the day or if you need to wait till a certain interval, et cetera, et cetera. So I told you guys a little bit earlier how we had a particular investment bank who partitioned by date and by location. This way, they were able to roll data in through the day for those different locations by date. But as we got into the evening time, so for instance, at 7 p.m., we didn't need to load data into New York anymore. We could do that in a little bit more lazy way, right? We didn't have to keep that quite as aggressive. We could back that off. Just like in the middle of the day here, we may not need to load some of the other time zones as aggressively. So it's interesting to see what some of the folks are doing with partitioning, because you don't just have to go in and say, well, what's the one column we're going to partition on? We have to pick one. It's never going to change. No, it's not a good approach. You need to be able to apply time, maybe product, and some other things that are going to be able to sort of consolidate and give you a lot more flexibility for how you're going to actually load your data. So we talked a little bit about cube flipping and ASLB. The other option you have is you can write a very small piece of C# code for an Excel plugin if you really want to get brave. But ASLB is not a bad option for prototyping and smaller to medium-sized cube environments. Just remember it's software-based, so once you get to a certain scale, it's going to pretty much plateau out. So you got to be careful with that. So we talked about rollup and molap in action. Really what we're looking at there is looking for whether we're going to put data in rollup or whether we're going to put it in molap, and how we're going to move it between each one, whether we need the latency on the front end or the speed from a query perspective on the front end. So once you get to a certain size, this slide will actually kind of walk you through the process for shifting data from rollup to molap, sort of a midday partition. You can use proactive caching up to a certain point, but you want to try to keep your rollup partitions small. Try to keep them very manageable. You really want to try to avoid those 100 million row rollup partitions. They're not going to do you a whole lot of good. You really also, I keep going back to locking, but it's really, really, really critical, because you're going to see it both on the source system and both on the cube as well, when you're doing, whether you're doing querying and processing or whether you're doing processing, and you're going to see that on the relational side. You really want to keep an eye on that as well. So, yes? One more time, proactive caching, is it better to use what? So the question was, is it better to use rollup if you want to use proactive caching? This is going to be one of those sessions, man. It can be. The bottom line is, it depends on how much time you have to process. So if you're going to use rollup and proactive caching, sometimes you could just process the rollup partition faster than you could wait for like a silence interval in proactive caching. So a lot of times the reason proactive caching stops working isn't because of the performance, it's because you have to give it a threshold. You have to say either wait this long for silence or just run it in, right? When it runs it in, it's going to lock, and it's going to cause a little bit of disturbance for the users. So if you got to cause that disturbance anyway, which there's still a little bit of disturbance even when you use rollup, you may be able to actually just process the rollup data in, as opposed to using proactive caching and then still having to reprocess after the fact. So it's a test and verify kind of thing. Yes?
Are there ever situations where the security model for a cube can impact performance as you get larger and larger?
Absolutely. So good question. Is there any situation where the security model for a cube can impact performance? Typically, if you have a lot of very, very granular security, a lot of very specific allowed and denied sets built into your roles, you may or may not see some issues on the formula engine side. So you won't see it on the storage engine side with the retrieval of data, but you may see that it takes longer to actually sort of create the plans for those particular queries, depending upon how complex their security model is. So, we talked about a lot of these things, but you have to get the design right. So your cube design is critical, whether it's security, whether it's avoiding things that are easy to implement when the cube is small but need to kind of be thrown out as it gets bigger, or really looked at like parent-child, many-to-many, certain types of implementations there. Partitioning is absolutely crucial. That's probably the understatement bullet of the day. We've got partitioning for processing speed, for getting rid of data latency, archiving old data. The only secondary issue there is it's really behind all of that for query speed. So your query speed should improve with partitioning, but at the end of the day, you're really trying to do it for all those other types of things. Hardware really matters. That probably wins the understatement, actually, not the partitioning. Really take a look at your solid state options. Take a look at what your SAN vendors can deliver as far as a larger tier 1 type solution with the hardware that you're already on. Doesn't mean you have to rush out and buy a new $2 million piece of equipment. It just means maybe you need to expand some capacity and change the way that you're looking at things under the covers. Some of the tests are showing that even a small number of cores can support a very large number of concurrent users if these design patterns and the I/O underneath it will support it. A lot of times we're doing a lot of extra CPU cycles and a lot of extra memory because the I/O underneath just won't support it. Locking's your enemy. We talked about that. I'm not going to beat locking to death anymore. You guys, I think you all know how I feel about that. From a multi-user setting perspective, some of the things, there's some server settings, and there's some server settings for processing. Definitely take a look at that Analysis Services 2008 performance guide that's out on SQLcat.com. It's a really, really good read. It walks through how the queries are executed and how those threads and jobs are looked at and addressed. There's also a really good book. If you really want to understand how this stuff is working under the covers, get the Analysis Services 2008 Unleashed book. It's a big orange book. It is a good reference book to have, especially for the chapters on the internals. The folks who wrote it are the folks who wrote the product. They're not product, managers or product team guys. They're the actual developers who sat down and wrote the code. It's Analysis Services 2008 Unleashed. Yep. Consider adjusting some of your threading values. So whether it's coordinator execution or whether it's coordinator balancing factor, there's a few different items you can adjust that are going to help you throttle threading for querying and processing. Play with those a little bit, but do not play with them, until you read that Analysis Services 2008 Perf Guide white paper, because it's going to tell you there's two different settings you can play with, and you only want to touch one, tweak it, kind of dial it in, and then go touch the other one. And it's threads and jobs. So threads kick off jobs to do work. Everything in Analysis Services is done with a job. But you don't want to mess with that jobs number until you've sort of pretty well dialed in that thread number. And that's really, really important. You don't want to have two threads that can kick off 100 jobs, right? You want to have the right number of threads that are kicking off at a normal, manageable number of jobs underneath them. AS, like the slide says, is send me any query. Your users can send anything they want if you don't restrict them. If you've ever queried with Excel, you already know that. Excel will generate some stuff that you may or may not be very happy with. But the important thing is just to get it right at scale. Just go into it with a very thoughtful process, and I think that you guys will do fine. So make sure that you fill out evaluations on mytechhead.com. Make sure you're entering and going through all the stuff to make sure that you can win any of the Xboxes that they're giving away. How many of you guys have seen a demo of Crescent since you've been here? All right, you like it? It's pretty good stuff, right? So if you go by the BI booth, you can compete in their little Crescent challenge, little puzzle challenge, and be entered to win. I think they're giving away an Xbox an hour whenever they're there. So that's not too shabby, right? So make sure you stop by and check out that. Sign up to be notified when the next CTP is going to be available, especially for SQL Server Denali. I think that's coming very, very soon. So make sure that you sign up to be on the notification list. We have all these different great sites from Microsoft, but the one that you really want to remember is, especially if you're in this session, is SQLcat.com, SQLCAT.com. There's tons and tons of resources, tons of white papers, and tons of great information out there. If you guys were pretty much right on time. So if you guys have any questions, I'll be here for a minute till the next speaker's ready to go, and then I'll be out in the hallway if you guys have any questions. Thank you very much.